So we were discussing last time about normal reaction as a self-adjusting force, and we saw that normal reaction or contact force it is the type of contact force that acts perpendicular to the plane of contact. Between any two surfaces in contact, and we saw that it is self-adjusting in nature. So let's just start with a quick question as a sort of quick revision of what we saw last time. So this time a slightly more tricky question compared to what we discussed earlier. So we have this equation now. We will discuss the assignment. We will discuss the assignment after some time. I just want to discuss few things in theory ahead first. Don't worry, I will give you a full breakup of the assignment and discussion of it in due course. So now we have this kind of situation. So somewhat similar to the question we did last time, but with a little bit more complication. So this is a combination of two smooth inclined planes. So this is, let's say, a solid sphere. It has a mass of 10 kilograms. Okay. And this is a combination of two inclined planes. So both of these are smooth inclined planes, but they are at different angles. We'll just discuss about that. So this one is at 30 degrees and this one is at 45 degrees. Okay. So this is smooth surface, let's say, labeled by E, and this is smooth surface labeled as B. So we have to first of all make the free body diagram for the solid sphere. And from that, calculate the normal reactions applied by both the surfaces. To start this question, take G as 10. Take each of the surfaces as A and B and calculate the normal reaction applied by each of them. Hope the question is clear to all of you. Right, hope the question is clear. You have to calculate the normal reaction applied by each of them. So just do the question in the order it has been asked. First make the free body diagram and show all the forces acting on it. Then apply the concept of Newton's second law. This is where we started from. Okay, this was just a quick discussion of, we took a quick recap of what we discussed last time. Okay, is it all right now? Yes, Tanish, that is correct. We have just started today's lecture with this question. So tell me quickly the magnitudes of forces, normal reaction by E and you'll get the answers in terms of root 2 and root 3. Yeah, Tanish, I'm recording the lecture, so don't worry if you miss some part. Okay, so first of all, let us understand the forces which are acting over here. So we have this incline at 30 degrees and this incline at 45 degrees, like this. And we have a spherical body. So as discussed last time, there will be a contact surface for each of the points of contact or for each of the planes of contact. So the force that the surface A will apply will be along this sort of direction. Along this sort of direction. It will be at perpendicular to this. Right? If it is perpendicular to this, it will be making an angle of theta with the vertical, which is the same theta that the inclined plane is making with the horizontal. So in this case, that will be how much? That will be 30 degrees. So because over here, what is happening is, because this angle with the horizontal, this angle is 30 degrees. So normal reaction NE, let's say, which is acting because of that, will be at 30 degrees to the vertical. At this point, if you drop a vertical, this angle will be 30 degrees. Okay, is it clear? And similarly, this other point where the normal reaction due to the second surface is acting. Yes, over. In this, you don't even need to think twice about the angle because it's 45 degrees. So it just bisects. So this inclined plane is making an angle of 45 degrees here. So this normal reaction NB, let's say, this is at this angle of 45 degrees. Okay. And so now if I make the proper free body diagram, this is just to understand the angles. The free body diagram will look like this. I have to represent the whole body by just a particle and show all the forces acting as if they are acting through the particle. So I should not show the inclined planes and all, I should just show the forces acting, and that too through that particle. So this is the weight which is acting vertically downwards, and the normal reaction NE, which we have shown over there, this surface will be like this, and the normal reaction NB, because of the other surface, will be something like this. So ये normal reaction NB हो गया, this normal reaction is NE, and this MG is vertical. Now we have to also identify all the angles. So remember that normal reaction makes same angle with the vertical. This is a simple rule of thumb you should remember. ये जो surface था, this was at an angle of 30 degrees. So यहाँ पे ये जो normal reaction लगा रहा है, this NA, that will be at 30 degrees to the vertical. Just remember this simple geometry. This angle will be the same as this angle. So that is why this should actually be more like this. This should be at 30 degrees to the vertical. So this angle here should be 30 degrees. Okay, yes, Smith. So this simple rule of thumb that we discussed last time, that when an inclined plane makes theta with the horizontal, then the normal to it makes the same theta with the vertical. Like if this angle is some theta, then anything over here, it experiences normal reaction in a direction which is making the same theta but with a vertical. Now, this is the simple thing. So this normal reaction direction will always be with respect to the vertical. It will make this angle. So for example, here this theta was 45. So ये वाला angle कितना हो जाएगा 45. 45 है तो it doesn't matter because the complement is also 45, but in general. So in these questions, this is the only thing you have to be careful about. The angle कौन सा वाला 30 है, कौन सा वाला 60 है, like that. Na? So this is done. Okay. Now what is happening? The body is in equilibrium. So it is in equilibrium. Or in other words, its acceleration is 0. So acceleration 0 है तो मतलब क्या हुआ? Net force 0 होना चाहिए. So vector sum of these three forces should be 0. So net force should be 0. Or if you see the vector sum of the weight, the normal reaction offered by the other two surfaces, ये कितना होना चाहिए? 0 होना चाहिए. Now to solve this, we have a couple of methods, but I'll tell you the easiest method. Remember, I was telling you while discussing vectors in the end that whenever there is equilibrium of three forces, we apply Lami's theorem. Okay, so easiest way of solving. Yeah, Somaru, we are discussing a particular question to do with normal reaction. So you can just follow up from here and later you can catch up from the recording. Next question onwards you can understand. So method 1 we can use is Lami's theorem. So Lami's theorem, I'll just quickly remind you the statement of the Lami's theorem, that if we have the vector sum of three things, like three forces for example, is 0. Okay. So suppose we have vector sum of E, B and C 0 such that the angle opposite to A is alpha, the angle opposite to B is beta, and the angle opposite to C is gamma. Then according to Lami's theorem, the condition for the sum of the three to be 0, condition for vector E plus vector B plus vector C to be 0 is that magnitude of A upon sine alpha should be equal to magnitude of B upon sine beta, should be equal to magnitude of C upon sine gamma. So this is just Lami's theorem. So here we'll apply Lami's theorem now. We'll see in this particular case, we had mg acting downwards, vertically downwards. We had normal reaction due to this one, Na acting like this, and we had normal reaction due to the other one, Nb acting like this, such that we saw that, just making a rough diagram now, because I've already made the fair diagram. 30 degrees ये था, और ये वाला angle 45 था. Okay. So then, what is this total angle becoming? Let's understand these angles. This angle will become how much? It will become 90 plus 60, so 120 degrees, right? और ये angle कितना हो जाएगा? 90 plus 45, so that is 135 degrees. Okay. And therefore, this angle will be how much? It will be 75 degrees. So that's one way of solving it. I can say that the vector sum of mg plus normal reaction E and B together is 0, implies from Lami's theorem that mg upon sine of 75 degrees, because the angle opposite mg is this one, 75 degrees, okay, should be equal to Ne upon sine 135 degrees, okay, should be equal to Nb upon sine 120 degrees. This is the Lami's theorem statement. Okay. Now, if you're not comfortable with this method, it's not necessary. You can always do by this thing also, by component method also. But this is, according to me, the most convenient. Now let's quickly just solve sine 75. तो हम लिख सकते हैं sine of 30 plus 45. So that will become sine 30 cos 45. So 1 by root 2 if you take common, sine 30 is half and cos 30 is root 3 by 2. So you can write this as 1 by 2 root 2 into 1 plus root 3. So that's sine 75. Okay. And similarly, sine 135 is the same thing as sine 45. second quadrant sine is positive, so it's 1 by root 2, and sine 120 is the same thing as sine 60, so that's root 3 by 2. So we'll have the statement that mg upon 1 by 2 root 2 into 1 plus root 3 is equal to normal reaction on this divided by 1 by root 2 is equal to normal reaction on this divided by root 3 by 2. Or we can simplify this a little bit more. So 2 root 2 mg upon 1 plus root 3 should be equal to Na into root 2 plus, sorry, not plus, is equal to 2 by root 3 times Nb. So from this you can see that Na will become 2 by 1 plus root 3 times Nb. Or you want to rationalize the denominator, you can write it as root 3 minus 1 times Nb, because 2 upon root 3 plus 1 will become root 3 minus 1. So that's your first thing. Okay. So normal reaction due to this surface should be this much. And then from the second one, Nb should become root 6 upon 1 plus root 3 times Mg, to which you can do the same treatment. So it will become root 3 minus 1 into root 3 by 2 Mg. This becomes Mg. So these are two ways of doing the question. Sorry, this is one method of doing the question, which is the Lami's theorem method. Okay. I'll just leave you to review the whole thing, including the statement of Lami's theorem. Okay. And we'll also see that there's also another method of doing it, the normal method of doing it, which is component algebra method. So I'll come to that also. So first of all, you understand, okay, that this diagram, the sphere lying between these two inclined planes, will convert into this force picture. Okay. And further, that force picture, in which you understand the two normal reactions acting, you can convert that into this free body diagram. Okay, this is the free body diagram, where you are representing the entire sphere by just a particle, which is the equivalent mass. Okay, and then you are showing the forces acting on it. Okay, so start from the question in case you joined it late. Okay, just make sure you understand the values given in the question. The mass is given as 10 kg, we have to substitute that in the end. But before that, the solving part. Okay, so this situation, okay, over here, this situation of the body at rest between the two inclined planes, it converts into, if you think about what kind of force the inclined planes are applying, it converts into this diagram. That I've shown to you, how we do the angles. Anytime the inclined plane is at theta to the horizontal, the normal reaction becomes at the same theta to the vertical. That is why this inclined plane, which is 30 degrees square, it will apply a normal reaction at 30 degrees to the vertical. And the other one, which is at 45 degrees, will apply a normal reaction at 45 degrees to the vertical. Now the thing is for equilibrium, because the body is at rest over there, so it's in equilibrium. So the acceleration is 0. The vector sum of these three forces should be 0. Once we have understood the free body diagram with the forces, next thing we have to solve the FBD in terms of Newton's second law. That is, in this case, the solution of the FBD is coming from this thing, that the sum of these three vectors should be 0. So calculating the sum of these three vectors as 0, the condition, I have solved it in my method 1 by using Lami's theorem. So you can make note of Lami's theorem in case you're not 100% familiar with it. Okay. It's a very simple theorem that comes from the same thing like sine rule in trigonometry. As you studied it, sine rule in trigonometry for a triangle, like that. Basically, see what happens is that these three vectors should form a closed triangle. If their resultant is 0, you can see that when you draw them head to tail, they should form a closed triangle. So if you draw A, B, and then C like this, they should form a triangle like this. So the condition of the triangle only is this. Okay. In the triangle, actually what is happening, this vector is B, this vector is E, and this vector here is C. Now you can see that the angle between B and E in the diagram, that one is gamma, the exterior angle. Okay. The angle between A and C in my diagram, the angle between A and C, you can see here, this angle is beta. Okay. And the angle between C and E, that is this angle here between C and A, is alpha. This angle is alpha. So you just apply the sine rule of the triangle now. So this angle is E, I mean this side is A, and this angle is pi minus alpha. This side is C, and this angle is pi minus gamma, on 180 minus gamma, and this side is B, and this interior angle is pi minus beta. So using the sine rule in trigonometry, from trigo, you have the simple statement of Lami's theorem. This one is called Lami's theorem. This is a condition for the resultant of the three vectors to be 0. Yeah, mg has to be substituted somewhere. M का value दिया हुआ है ना, it's 20 kg. Sorry, as 10 kg, whatever. So mass is given to us. So finally, in the end, we have to substitute. Okay. So I'm coming to that last time, but I got everything in terms of mg. So now applying Lami's theorem to this particular question. Apply Lami's theorem to this particular question. So the three vectors which you add are the ones which we had shown earlier also. These three vectors, this diagram, इसमें resultant 0 होना चाहिए. So this is the condition which you are getting from Lami's theorem. Okay, so just note this down and understand the values from this, and then try it by component method also. I will also solve this question for you by the component method next. Yes, Piyush will come to the component resolution method also. Okay? But as I said that whenever you are adding three forces to become 0, equilibrium of three forces, the first method of choice should be Lami's theorem. It's the simplest way. It's the easiest way of solving the question. So here you substitute mg now, so you can see that Na is becoming root 3 minus 1 into 100 newtons. So that will approximately become, take root 3 as 1.73 approximately. So 73 newtons approximately. And from here, NB becomes, you can write this as 3 minus root 3 by root 2 into NB. Sorry, into mg. So that's 100. So that will become approximately 3 minus 1.73 divided by, now this you can write like this, into 0.7 into 100. Because 1 by root 2, you can always write as root 2 by 2, approximately 1.4 by 2 or 0.7. So this is becoming how much? This is becoming 1.27. into 70. So that will become how much? So nearly 89, close to 89 newtons. Okay, this is clear, I hope. Okay, now the other method is to solve this by equivalent method. Resolve vectors, that is the forces, into components. Now, generally speaking, this is the more common method that is used. It is only when there are three forces and you are calculating equilibrium of three forces that we prefer the Lami's theorem method. So यहाँ पे ये वाला force NA है. Then you have at 45 degrees the other force NB, and you have the weight, the third vector. Yeah, Somarup or Tanish, lecture 3 was conducted as per your schedule. You can check out the schedule. You would have got the schedule. So these are the, so this is 100 newtons. The other two we have to calculate. This angle is 30 degrees. This angle is 45 degrees. Yeah, Yasmin, in the question is given that the sphere is resting between the two inclined planes. It's not in motion, it's resting. You can see it's resting between the two inclined planes. Now, the sphere is just lying like this between the two inclined planes. So where it will have to be in rest. Like that. Okay. So now what you do is you take this as your x-axis and take this as your y-axis and resolve the forces first. So when you resolve the forces, which one you have to resolve? NA and this. Okay. You can also see that this angle is 60 degrees. And this angle is of course 45 only. So पहले NA को resolve कर लो. So normal reaction E, when you resolve it, what will be the components? With the x-axis is making 60 degrees. So this one will be how much? It will be NA cos 60. So that is NA by 2, which is the same thing as NA cos 60 degrees, or NA sin 30, whatever. And the other component, the vertical one, will be root 3 by 2 NA. Or NA sin 60 or cos 30 or whatever. Similarly, resolve the other one, resolve NB. So when you resolve NB, you will get the horizontal component to be in this side, and this angle is 45. So the magnitude of this component will become 1 by root 2 times. So ये वाला component कितना आ जाएगा? This will come out to be NB by root 2. And similarly, there will be a vertical component which will also be NB by root 2. Okay, so Tanish and Somarup, if you missed the third lecture, don't worry. You just go through the recording and try out the questions. I will help you out with it later. Okay. Right now, just concentrate on this, and you will see that you will be able to follow today's lecture because it's a different set of concepts within Newton's laws that we are discussing. So after resolving the forces, we are getting this step to this step, we have resolved forces along the axis, that is the x-axis and y-axis. Okay, so ये step हो गया मेरा. Oh, like that, Tanish. Okay. So, okay, just go through the recording, beta, and if required, just talk to me sometime tomorrow or day after. Once after you go through the recording, I will let you know. It will repeat in some other batch also, so you can join in at that time. Okay. Tanish can summarize, in case you need to repeat the lecture 3, you have the recorded lecture in this batch also, but otherwise the lecture will get repeated in other batches also. There are other batches which are running behind blue house. Like there is yellow house, there is orange house. So at some stage you can just be in touch with me in case you need to repeat the lecture. I'll give you the contact at that time. Okay. But if you've done the first 2 lectures of vectors, you will be able to understand the today's lecture perfectly, because today's lecture is just about application of vectors in that only. Okay, so don't worry about that so much. Now we will see that यहाँ पे क्या हो रहा है, net force इसमें 0 होना चाहिए because इसका acceleration 0 है. So now we should apply the condition that the net force is 0. So now the equation solving part comes. Okay, so net force अगर 0 हो रहा है, तो क्या हो रहा है? Along the x-axis, the net force should be 0. So this force Na by 2 should balance this force Nb by root 2. And along the y-axis, these 2 forces which are upwards should together balance mg. So let's see what those equations are giving us. Okay, so acceleration is 0, implies the net force is 0. Now break this into components. So along x-axis क्या होना चाहिए? Summation of all the forces along x-axis should be 0, and along y-axis, summation of all the forces along y-axis should be 0. So if you just look at the above diagram, you can see that along my x-axis, what all forces are acting. There is along the positive direction, there is plus Na by 2, that component, and along the negative direction, there is minus Nb by root 2. So this should be 0, and that becomes my first equation. Similarly, along the y-axis, what is happening? Along my positive direction, upwards, I have Nb by root 2 plus root 3 Na by 2, and along the negative direction, I have minus Mg, and their resultant should be 0. So that becomes my second equation. So now what I have to do is I have to solve equation 1 and 2 as simultaneous equations. This is my summation fx is 0, and this is my summation fy is 0. Now next step, we have to solve equations 1 and 2 simultaneously as simultaneous equations to find the unknown quantities Na and Mg. Remember that Mg is already known to us, it is 100 newtons. So in the above equations, we have only 2 unknowns and we have 2 equations. So that becomes the game for solving Newton's law type of problems, that the number of variables should always be equal to the number of equations we have got. So यहाँ पे कितने variables हैं? The 2 forces Na and Nb are unknown. So we have 2 variables. So we have to generate 2 equations. So we are generating the 2 equations by using Newton's laws. So in this case, by keeping the component 0. Now when we were solving earlier by that this thing method, Lami's theorem method, how we got 2 equations? Because we got Mg by sine of some angle alpha is equal to Na by some sine of some other angle beta, and that is equal to Nb by sine gamma. So in this there are 2 equations actually, because we are equating this with this, you are equating this with this, or you are equating this with this. So there are 3 equations, but out of them 2 are consistent. So whether you are using Lami's theorem or you are using component algebra method, ultimately you are just using Newton's second law to get 2 equations for the 2 variables. दो चीजें unknown है Na and Nb. तो उनको solve करने के लिए we need to get 2 equations and then solve it simultaneously. Okay. So once again, I'm just giving you some bit of time to first go through the resolution of the vectors. Please ask me if there's any doubt with the resolution part. Why this is root 3 by 2, why this is 1 by 2, because the angles you can correlate from here. Once you're done with the resolution, now you have to make individually along x-axis the force should be 0, and individually along y-axis the force should be 0. Yes, Sarvesh, I did not understand. What exactly is your question? -1/√2. तो वो डायरेक्शन दिखाया हुआ है ना, NP का जो x component है, it is along the negative x-axis ना बेटा. So this is only the magnitude. Yeah, it's along the negative x-axis. So the arrow is pointing along the negative x-axis. So that's why in the equation when we're doing summation fx, you see that comes with a minus sign. You're getting my point now? See, if I wrote it as a vector, I would have written it as -nb/√2 I cap. No, but I'm just writing it as a magnitude over there. So mod of this thing is how much? It is nb/√2. The direction is shown by the arrow. हाँ तो ठीक है ना बेटा, तभी तो ये वर्टिकल कंपोनेंट पॉजिटिव है ना. If you look at this force NB, Sarvesh, if you look at the force NB, it's making how much angle with the x-axis? It's making an angle of 135 degrees with the x-axis. That's why its x component is negative and its y component is positive. So if I were to write NB like this, I would understand that as a vector, it would be -nb/√2 I cap plus nb/√2 j cap. So this only we have shown in the vector diagram. No? We have shown this component to be along the positive x direction and the x component to be along the negative. Which one is 120 beta? 150? No. Achha, it should be 150. Yeah. Just let me check one moment. Correct. Okay, people, there's a correction here. This angle is not 120. This angle is 150. Please make a correction here. Okay. So this angle. So I'm just making the correction in a different color so that you can see. This angle in the Lami's theorem method, this should be 150 degrees. Okay? So this will become 150 degrees. Okay? So sin 150 कितना होता है? Half होता है. Okay. So this will change. It will become sin 150. It will be sin 30. It will be half. Okay. So let's just get the new values from this. So this should be half. Okay. So that actually makes life simpler. So when we solve this, NA is fine, but this one will get as different. Okay. So we get this as NB will be equal to that 2 will it will become 4√2 upon 1 plus √3 times mg, or we can write that as 4√2 into √3 minus 1 by 2 mg, or it becomes √2 into 2√2 into √3 minus 1 mg. Oh, my mistake. So this is becoming half. This is, yeah, wait a second. I got it. Okay. Just give me a second, guys. ये तो ठीक है. Okay, this one will become, this 2 will go in the numerator. Correct. So once this goes in the numerator, NB will come out to be how much? So this 2 goes in the numerator, so this 2 and 2 cancels. So NB comes out to be √2 upon 1 plus √3 mg, which we can write as √2 by 2 into √3 minus 1 times mg. So √3 minus 1 mg was already 73, and this will become that divided by √2. So this will come out to be 0.7 times this. So 0.7 into 73 कितना हो जाएगा? 7.3 into 7. 51 point something. 51.1. So it will be approximately 51.1 newtons. So just make a correction. And anyway, we are going to check with the one below. So let me come back to the Lami's theorem diagram, and you will see why the angle had to be changed. See, this is the proper diagram. Okay? Just magnifying it. यहाँ पे देखो, ये जो normal reaction है, वो 45 to the vertical पे act करेगा, और ये जो normal reaction है, वो 30 degrees to the vertical पे act करेगा. And apart from this, there's of course mg also, which I had not shown in this diagram, but that comes below also. So the forces acting are like this. So that is why, see, this angle was, I had wrongly taken it to be 120, but this angle is 150. Okay, and this angle is 135. Okay, and this angle is the sum of these two, so it is 75. So our statement of Lami's theorem, when we write it, should be mg divided by sine 75, should be na divided by sine 135, should be equal to nb divided by sine 150. So that is what we have now written. This. Okay, with the correction, we have written it properly. So when you solve this, you will get what I. Alright. Now let's come back to my component algebra method and solve the equations and see whether we are getting the same or not. So anyway, thanks for pointing out Devansh. Otherwise I would have got the different value. Okay, so anyway, now let's solve these two equations. So let's see how we'll solve this. Okay. So I have this thing. यहाँ पे NB by root 2. So let's start by this. So according to this equation, from equation 1, I can substitute NA by 2 equal to NB by root 2. That means I can substitute NB as NA by root 2. Okay, NB can be substituted as NA by root 2, correct? Now substitute this in equation 2. So I have NB by root 2 plus root 3 by 2 times NA. Now NA कितना हो जाएगा? Sorry, NA को तो रहने देते हैं. We have to substitute NB. So let this be. So NB is multiplied by 1 by root 2. So 1 by root 2 into NB, which we will now write as NA by root 2. This thing. Plus, so this is done now, plus root 3 by 2 times NA should be equal to mg from equation 1. Just bring mg to the other side. So now what is happening here? 1 by 2 is common. So I have 1 plus root 3 by 2 NA is equal to mg. So we are getting NA as 2 upon 1 plus root 3 times mg. And we'll multiply divide by root 3 minus 1. That's simple. Rationalize the denominator wala concept. So this will become 2 into root 3 minus 1 upon 3 minus 1 is a square minus b square times mg. So as usual, this is what we got. So 0.73 into 100. So approximately 73 newton. The same value we got earlier. ये Na आ गया. और अब मैं क्या करूँगा? Directly NB को क्या substitute करूँगा? NB here should be Na by root 2. So NB should be equal to Na by root 2, which is approximately 0.7 times Na. So always we take 1 by root 2, तो solve करते हैं strict से. That is root 2 by 2, which is approximately 1.41 by 2. So approximately 0.7. If we round up to first place of decimal, it's approximately 0.7. So 0.7 times Na. So that will become that 0.7 into 73. So that was 51.1. So now because we made that correction in the Lami's theorem angle, which was the problem earlier, now I'll get the correct answer because this and that one will match. You see that with the correction, we had got the normal reaction as the correct values in the Lami's theorem method. With the correction, we had got it as 51.1 and 73. Okay. But you can see that this method is lengthier. The Newton's laws approach is lengthier because you have to solve simultaneous equations. So that is why wherever we can avoid it by using a trick like Lami's theorem, we avoid simultaneous equations. Okay. Lami's theorem is a single line equation. You can see above that this was giving us a single line equation, this one. This was the Lami's theorem equation, which was a single line equation. Whereas here you have to first resolve the forces, then balance the forces along x-axis, then balance the forces along y-axis. That is why anytime there is equilibrium of three forces, okay, we should use Lami's theorem. Ranak, you were referring to that Lami's theorem equation, right? 2nb. So anyway, guys, hope this problem is clear for you. By both the methods. Okay. Now let us look at one more problem based on this normal reaction concept before we move on to tension. Now this is something for you to solve. Okay. So what is happening this time is that we have a 30-degree smooth inclined plane. So we have a block like this lying on the inclined plane. This angle is 30 degrees. Now, case 1, the block is released from rest. Case 2, an external force of F equal to 20 newtons is applied parallel to the inclined plane. Okay, up the plane. So in case 2, on this block we are applying this kind of force parallel to the inclined plane but up the inclined plane. And in case 3, an external horizontal force newtons is applied into the block. That is, in this case, ये block अगर ऐसा है, this is the horizontal direction. Now we are applying a force like this now, horizontal plane force, which is driving it into the inclined plane, towards the inclined plane. Kind of a force is applied to the block. So in each of the cases, you have to make the free body diagram and calculate the blocks. So make 3Ds, free body diagrams. For each case, find the block's acceleration and the normal reaction between the block and inclined plane. So in the case 1, we are not applying any force, we are just releasing the block from rest. In the case 2, we are applying a force but in this manner, parallel to the inclined plane and in the direction of the inclined plane. And finally in the third case, we are applying the force horizontally, kind of pushing it against the inclined plane but by application of a horizontal force. Okay. Take G as 10 meters per second square for this. G's direction is vertically downward like this. So try and work this question out. A lot of concepts will get cleared by making the free body diagram correctly and resolving the forces correctly in this problem. So take your time, use all the concepts that we discussed about inclined plane, how to work out the angles between the horizontal, vertical, normal and tangential direction and all these things. So this part that we are learning today is very, very important. Okay. Free body diagrams with the angles properly labeled and resolution of the forces. Now, major part of learning in vectors has been so that we can solve these type of problems with the application of multiple forces. No, Sarvesh, we have to consider one situation at one time. Okay? So I'm just making the free body diagram for the first part. So in the first part, I'm just releasing the block. Okay, I'm not applying any other force on it. So when I just release the block without applying any additional force on it, so it will come sliding down the inclined plane. So it will come down the inclined plane with some acceleration because there are two forces which are acting on it: the weight mg and the normal contact force n. So in case one, when I make the free body diagram, I'll have to show that there are two forces mg which is acting vertically downwards, and normal reaction is going to be acting like this. So normal reaction ऐसा होगा, we see mg will be such that if this is your axis which is normal to the inclined plane, this is the line along which the normal inclined plane is acting. The normal to the inclined plane is there, and this is the inclined plane's axis itself. So coming back in this diagram, you can see that this is that axis along which normal reaction is acting. So as we've discussed earlier, that because this angle, the inclined plane's angle with the horizontal is theta, therefore here this angle will be theta. So therefore in this diagram, this angle will be theta, and theta in the question was 30 degrees. Yeah, so theta was 30 degrees. So this is the free body diagram as far as forces are concerned in the first part. Okay, only these two forces are acting, and with these two forces, uska acceleration kaisa ho raha hai? The acceleration vector is along this direction. It's sliding along the inclined plane, along this direction. So the acceleration vector will be like this. It will be along this. The acceleration will be like this. There are only two forces acting, very simple, mg and normal reaction. अब बाकी geometry है. We have seen n number of times by now that if your inclined plane is at theta to the horizontal, whatever that angle theta is, in this case it's 30 degrees, then the direction which is perpendicular to it, this direction, this one, is at the same theta with the vertical. That simple rule of thumb here, this angle here or this angle here, they are the same theta as this. So that's concept here. Okay. So this picture, now just fix it in your mind that the angle between the normal direction, the perpendicular direction, and the vertical direction is always theta, the same as the angle of the inclined plane with the horizontal. ये वाला एंगल जितना भी होता है, ये एंगल उतना ही होता है. Okay. Now the very critical step here, so free body diagram is there. Now the very critical step here, that since the acceleration of the body, since the acceleration is along the inclined plane, we will not take x and y axis as vertical and horizontal. We will take our axis, take the x axis along inclined plane. There's no hard and fast rule that we have to take the x axis along the horizontal. We can take x and y axis as we please. So we will do what? We will take the x axis along this because this is happening. So next step, we will take this direction as our x axis. We will take the inclined plane, this direction, as our x axis, and we will take the perpendicular to the inclined plane as our y axis. So in this diagram, this axis will become our x axis, and this axis will become our y axis. So having done that, now we will resolve forces. So in this case, which force we have to resolve? mg, because normal reaction is already resolved along the chosen axis. The chosen axis, which are the inclined and the normal axis. So free body diagram, beta, yes, in the free body diagram, you are just representing the block or whatever body you have as a single particle, and you are just showing whatever forces are acting on that block or on that body as the forces acting through that particle. So there are only two forces, weight and normal reaction. So on the body, only two forces are acting. That is weight and normal reaction. So that is the concept that we've used to now make the free body diagram of the given body. No, this is not an equilibrium because it's sliding down the inclined plane. Yes, obviously in this case it's not an equilibrium. Okay. You can see that the block is sliding down the inclined plane. Now additionally, हम क्या देख रहे हैं कि the acceleration's direction is along the inclined plane. So it will be more clever, it will be more convenient for us to take the x-axis along the inclined plane. Okay. This is a better option. We can take the x-axis along horizontal also, but this is more convenient. This is more convenient to solve by taking the x-axis along the direction of acceleration. Okay, so this is a trick that we use in Newton's laws. Anytime we have a block or a body or a sphere or anything that is coming down an inclined plane, we don't take x-axis horizontal and y-axis vertical. We don't do this. We take x-axis like this along the inclined plane and y-axis perpendicular to the inclined plane. Why? Because it becomes more convenient. Then my y component of acceleration becomes 0 and the x component of acceleration becomes whatever the e is. Okay, so why it is more convenient? Because now my y component of acceleration will become 0 and my component of acceleration will become the net acceleration. So because of this reason, it is more convenient, and that is why we do this. We take the x-axis along the inclined plane and y-axis naturally has to be perpendicular to that. So choice of axis is very important. Okay, this is very important over here, that once you made the free body diagram, you make choice of axis, the proper choice of axis. That is according to convenience. That is according to what is convenient. In this case, this is the convenient thing. Okay. So having done choice of axis, next step what we have to do, we have to resolve the forces. Okay. So let's come back to our free body diagram and our axis first. Then we'll resolve the forces. So this was our normal direction, and this was our inclined plane. So these are our axes. So in my system, I have taken this as my x-axis, this as my y-axis, and now what was happening? mg was a force that was vertically downwards like this, okay. And the angle was like this. This angle was theta, where theta in this case was 30 degrees. So when I resolve mg in my new diagram, how the components of mg should look like? Now you can see that mg will have one component along the negative x direction, along the x direction, one component, and have one component along the negative y direction. ये mg के components होंगे. These will be the components of mg. And how much will this component be? This component will be mg cos theta. So that is mg cos 30 root 3 by 2. And how much will this component be? It will be mg sin theta. So that is going to be mg by 2. This is the component of mg into, or basically you can say perpendicular to the inclined plane. That is the negative y-axis. And this one here, this is the component of the gravitational force parallel or along the inclined plane. ये दोनों components हैं, ठीक है. And अभी दूसरा कौन सा force था मेरे पास? Normal reaction. So that is just drawn the way it is. There was no need to resolve it. Normal reaction was directly acting along the y-axis only, so there was no need to resolve it. So this normal reaction acts perpendicular to the inclined plane, that is along the y-axis. Okay. So first of all, you make sure that this is clear. The distribution of the forces. Original diagram में क्या forces थे? दो force थे, normal reaction and weight. मैंने x-axis कौन सा लिया? Down the inclined plane. Y-axis perpendicular to the inclined plane. So I had to resolve which force? I had to resolve mg. Normal reaction was already resolved. So on resolving force like this, mg, x-axis like this, y-axis like this, because this angle is theta. So when you drop this perpendicular, ये वाला component कितना हो जाएगा? This component will become cos component. And because this angle is 90 minus theta, so when you drop this perpendicular, this component will become how much? This will become mg sin theta. So mg is replaced with its components in this diagram. That is what we've done. We've resolved the weight mg into components which are accordingly. One component is into the inclined plane or perpendicular to the inclined plane, the other component is parallel to the inclined plane. No, Pratyush, Lami's theorem we can't use here. Why? Because the net force is not zero beta. The vector sum of the three is not zero. It's an actual case where now the body has an acceleration. So you can see that this body is not in equilibrium. It's actually accelerating down the inclined plane. So it has an acceleration vector. Okay, but is it clear, Pratyush? Remember, Lami's theorem is only and only used when we have equilibrium of three forces. We cannot use Lami's theorem when the body is in motion or it is in a what we call a dynamical condition. It has some dynamics. It's not static. So that is the interesting thing, surveys. The normal reaction is balancing it. वही तो self-adjusting force है ना? It doesn't allow the body to go perpendicularly downwards. It goes along the inclined plane. The inclined plane is supporting the body, na? So it's going against the inclined plane. Understood the point, Sarvesh? अगर मैं normal reaction, अगर मैं फट से inclined plane को हटा दूंगा यहाँ से, तो क्या होगा? The block will, if I just remove this inclined plane, the block will just fall down vertically. But while that inclined plane is there, it is supporting that, na? So it's not allowing the motion along this direction. The motion is only happening along the inclined plane. Yes, correct. That is correct now, Sarvesh. Okay. So now, we are done with step 2. We have resolved the forces. Okay. Now let us come to the next step, which is application of Newton's second law. That net force should be equal to mass into acceleration. अब हम उसको कैसे express करेंगे? By taking the components. Along the x-axis, there is acceleration e. Along the y-axis, the acceleration is 0. But remember here, x and y-axis are not horizontal and vertical. X and y-axis are along the inclined plane and normal to the inclined plane, like that. Okay, so let's go over the sequence of the steps again. So first thing is, we understand the force picture. That what is happening in this first case is that in case 1, what was happening in this first case is that we release the block from rest. Okay, so we release it from rest, no external force separately applied. So there are only two forces acting on it, weight and normal reaction. And under the action of these two forces, the body will slide down the inclined plane with acceleration e. which we want to find out, with how much acceleration we want to find out. So this picture, we start with this picture. Then we convert this into a free body diagram. So the free body diagram is showing you the two forces, normal reaction and mg, and the direction of acceleration is along the inclined plane. So once you see your two forces, now you have to decide कि अच्छा मुझे axis कैसे लेना चाहिए so that I can resolve. ठीक है? Now one choice is you can take your axis as you normally take, that x-axis is horizontal and y-axis is vertical, but that will not be convenient because then I'll have to also resolve the acceleration vector into x component and y component. So better is that our choice of axis, for convenience sake, how we take, instead of taking x-axis as horizontal, we take the x-axis only along the inclined plane. So my acceleration is along the x-axis, and by choice then my y-axis will have to be perpendicular like this. So there won't be any acceleration along the y-axis. So these two things come into play. That because we have chosen our x and y-axis accordingly, our y component of acceleration is 0 and our x component of acceleration is e. So having selected our axis, now what we have to do, we have to resolve the forces. So next step, resolve the forces along the chosen axis. So which inertial frame I'll come to later. Okay, inertial and non-inertial we'll discuss later. Right now you just think that any frame fixed to the ground is an example of inertial frame. So as the reference frame, as the observer, we are not moving. We are fixed to the ground. So that's an example of inertial frame. And we are applying Newton's second law in inertial frame. Okay. It will take us some time to come to non-inertial frames, but if you like, you can read ahead from René Descartes about inertial and non-inertial frames. Right now, we should not be bothered about that. We are solving everything with respect to fixed ground frame. Yeah, in H.C. Verma also it is given. Yes. Hey, H.C. Verma, beta, the theory is very short, so they introduce the concept very fast, okay, without getting into too many things. Yes. Sarvesh, H.C. Verma, you should not use it as a book for reading the basic fundamental concepts, because the theory portion is given in too much, like just like the main points are listed out. It's not given in detail. Once you've studied the chapter, if you want to do quick revision, then the H.C. Verma is good as theory notes for revision, but it is not good for understanding the basics. The questions are very good for understanding the basics. Okay. So for understanding the basics, my lecture notes, then Resnick Halliday, then if you have NCRT, instead of Resnick Halliday, you can go with NCRT also. So it's very boring to read NCRT in comparison, that is. Alright, so my forces are resolved. Now the next thing is apply Newton's second law. So the final step is application of second law, that is net force is equal to mass into acceleration. Now we will do this in component form. So in component form, when we write this equation, net force is equal to mass into acceleration. Along the x-axis, it becomes summation of fx to be equal to mass into x component of acceleration. And along the y-axis, it should become summation of fy is equal to m into ay. Our no major difference. Very small minor differences between the two additions. You can study from either of them. It's not a problem. Okay, so coming back to our particular example, क्या हो रहा था यहाँ पे? For us, along the x-axis, there was only one force acting on the body. Along the x-axis, there was, one component of a force, which was mg sine theta. Theta was 30 degrees. Whereas along our y-axis, there were two forces, and they are actually cancelling each other, because the y component of acceleration would be 0. So there was this normal reaction, and there was the other component of mg, which was mg cos theta. Okay. And the body was accelerating only along the x-axis. The acceleration of the body is along the x-axis. Okay. So here, Ex should be substituted as E, which is the net acceleration. because ay is 0. Okay. So let us say now this is going to give us equation 1 and this is going to give us equation 2. So let's solve. So दो unknown है मेरे पास, normal reaction and acceleration A. So from each of the equations I'll get that. So from equation 1, you can see along the x-axis, left hand side, summation fx is how much? It is just mg sine theta. And on the other side, it is ma. So what is the acceleration? It is g sine theta, or it is 10 into sine 30. So in this case, the acceleration will have a magnitude of 5 meters per second square, and direction will be along the inclined plane. It will be sliding along the inclined plane. And from equation 2, you'll see that the net force along the y-axis will be n minus mg cos theta, and the y component of acceleration is 0. When you do for the second equation, see when you see the left hand side, summation fy, वो क्या होना चाहिए? इन forces का y-axis के along forces का vector sum होना चाहिए. So there is plus n and there is minus mg cos theta. So their sum should be m into ay, where ay is how much? 0, because we know that it's sliding along the inclined plane. So the y component of acceleration should be 0. So this tells us कि normal reaction का magnitude कितना होना चाहिए? mg cos theta, or again that should be equal to, what was the mass we had taken? 55 kg. So 50 into root 3 by 2. So 25 root 3 newtons will be the normal reaction. Assuming I have taken the mass correctly, I'll just check once. But here I have taken mass as 5 kg. So this becomes the complete solving of this. Now it will seem to you right now that there are so many steps involved in this, but just be a little bit patient in the beginning, and as we solve more and more questions, you will get into a position where you can see some of the steps directly. You don't have to always, work out everything in so much detail. But in the beginning learning part, make sure you do the steps of this method correctly. I will list out for you right now a very simple method also of all these steps. Step 1, make the free body diagram. Step 2, show the forces on it. Step 3, resolve the forces. And step 4, apply the Newton's laws. So we'll list that down as a systematic method of solving. So just taking you through the free body diagram and its resolution once more. So this is the FBD, this one. Then below it, the resolved form of it we'll see, and then finally the application of Newton's second law. I'll show you better how we equate. I'll just take you through it. So first of all, force picture. Okay, then next thing, axis मैंने select किया convenience के हिसाब से, so that is done. Having selected the axis, the next thing, resolution of the forces. This is where your vector algebra comes in. So if any vector is making an angle theta with any sort of direction, like let's say with this direction, it's making theta. So with the perpendicular direction, it's making 90 minus theta. So उसका जिसके साथ भी थीटा एंगल है, वो वाला कंपोनेंट cos हो जाता है, और जिसके साथ भी एंगल 90 minus theta होता है, वो कंपोनेंट क्या हो जाता है? sin हो जाता है. So just remember the resolution this way. So if this angle is theta, trigonometry wise this is cos component, and trigonometry wise this is sin component. So this can be for any direction. So for example, you have a vector b like the cos component. The sin minus theta. So this component, it was actually acting vertically downwards in this direction. It was acting like this. This angle was theta. Yeah, sorry people, I seem to have lost connection for a moment. Should be back online. Just give me a minute, people. I will get the other screen online also. An interruption in my net connection. So I'm just yeah. So I think things are back online now. Right. So I was just explaining. So this angle of mg is acting vertically downward. This angle is theta. That's why this component of mg is mg cos theta. Whereas this component of mg, ये वाला angle theta है. So this angle is 90 minus theta. That's why this is mg sin. So now the two forces that you had, normal reaction and mg. Normal reaction, you're leaving it the way it is because it was acting perpendicular to the inclined plane. But mg is now broken into the two components. Mg cos theta going straight into the inclined plane or opposite normal reaction, and mg sin theta which is parallel to the inclined plane. So you'll realize कि mg sin theta ही वो force है जिसकी वजह से वो slide कर रहा है along the inclined plane. It's frictionless, so there's nothing to balance it. There's nothing to challenge that force. So that component of weight which is along the inclined plane, that is the force that is pulling it down the inclined plane with acceleration. Whereas the other component which is just going into the inclined plane, that is just creating contact. That is pushing the particle or the body against the inclined plane. So inclined plane क्या कर रहा है उस पे equal and opposite ऐसा normal plane. Okay. So this thing now we have to just express in equations. So what we'll do next is we'll apply F is equal to ma separately along the x-axis and separately along the y-axis. Now along the y-axis the acceleration is 0. So the net force should be 0. Whereas along the x-axis there is only one force, mg sin theta. So it is creating an acceleration of g sin. So that is where the third and final step comes in. That Samad is not that we are always taking smooth inclined planes. It's that we will learn about rough inclined planes with friction in the next stage of our chapter. In the first stage of this chapter, to learn the basics, we are dealing with a simpler situation where we are assuming the surfaces are frictionless. Once we get a little bit used to these situations, then we will move on to the second part of this section of dynamics, where we look at Newton's laws with friction. So in most of the textbooks also you will see the chapter is divided into two parts. The first part where you're dealing with frictionless surfaces. And the second part, the chapter is only usually called friction. But it's actually a continuation of the same thing, Newton's laws, but applied in a situation where we are dealing with rough surfaces. Okay. So don't worry about friction just now, but 3 or 4 lectures down the line, we will discuss about how to incorporate friction into these. So anyway, so now, yeah, JEE obviously, but JEE will have questions from both situations where there is friction on a surface as well as where there are smooth surfaces. So it's like friction just adds one complication. एक और complication add हो जाता है. The method of solving is the same, but there's just one more force to deal with, which is the frictional force. Yeah, NEET also. NEET will also. I mean, this is part of your basic mechanics syllabus. Newton's laws of motion with and without friction, both. Okay, so just make a note of these final equations and steps. Okay, then we'll come to part 2 and part 3. So now I'll just get you started in part 2 with a diagram, and then you convert it into free body diagram and all yourself. Okay, so in part 2, what is happening for us is that rest everything else is the same. The inclined plane is at the same angle, it's still a smooth inclined plane and all that. But साथ में हम क्या कर रहे हैं? We are also applying another force on the body. Same body or same mass. So again, no difference there. So most of the things are same. This is 30 degrees. This is a smooth surface. And you have a 5 kg block. Block, but now additionally, I'm applying a force parallel to the inclined plane. Remember, we were applying an external force parallel to the inclined plane of magnitude 20 Newton. So, in case 2, an external force of magnitude 20 newtons is applied parallel to the inclined plane. So again, sorry, it's applied parallel to the inclined plane. Now from that you have to draw the free body diagram, show forces, and find acceleration and normal reaction. So just one force is added to the previous situation. So start with that same free body diagram and resolve the forces and all, but just incorporate that additionally, there's a 20 Newton force that is acting up the inclined plane. And remember to take G as 10. Normal reaction force, we have got it as mg cos theta, so root 3 by 2 mg. Okay. Just a moment, the normal reaction was this. So in case you haven't noted down that part. Yes, very good. That's correct, Aditya. That's correct. What about the direction, Aditya? Which direction it is accelerating? Is it the direction of the force or is it down the inclined plane? Yes, very good. That's correct. So Aditya, you can move on to the third part. Yes, Devansh correct. Devansh and Devash, both of you got the correct answer. But you have to tell me the direction as in down the inclined plane or along the force. ऊपर जा रहा है कि नीचे की तरफ आ रहा है, down the inclined plane. Yes, so acceleration will come 1 meters per second square down the inclined plane. So let's understand how. So first of all, I'm making the free body diagram for all of you to understand. So my free body diagram this time will have one additional force compared to last time. We have one force that is up the inclined plane. This force 20 newtons magnitude, and of course I have normal reaction the way we had earlier. And it will have weight. Again the way we had earlier. The weight is 15 newtons. 5. Now the thing is, see, we know that the acceleration will be along the inclined plane. Now the thing is, this along the inclined plane may be up if F dominates, or maybe down if mg sin theta dominates. But jo bhi hai, it will be along the inclined plane. So that is why our choice of axis, should be the same. It should be x-axis parallel to inclined plane, and y-axis perpendicular to inclined plane. Be like this. Okay. So once again, we should take our x and y-axis as the same system. So follow the same principle for taking the choice of axis. In fact, generally speaking, always for an inclined plane, we take the same choice of axis. And always remember the simple principle that whatever inclined plane is making with the horizontal, mg makes same with the vertical. So this theta will be 30 degrees without fail. This angle and this angle will always be the same. Okay, so having understood that, now that we take our x and y axis like this, now next step what we have to do, we have to resolve our forces. So यहाँ पे कौन से force को resolve करना है, एक ही force को resolve करना है, and that is this one. So to resolve only one of all these forces, and that is the mg. So after resolving mg, what will our FBD look like now? Resolving mg into x and y components. So let's take a relook at our free body diagram. So inclined plane, normal to inclined plane. So this is my x-axis, this is my y-axis. So as usual, mg का जो component into the inclined plane होगा, which component will be the cos theta component. So this component of ours will become mg cos theta. So in this case, root 3 by 2 times 15 newtons. mg का जो component along the inclined plane होगा, that will be mg sin theta. In this case, this will become 50 into half, because this angle with the vertical was 30 degrees. This angle was. Okay. And along with this time we had two additional forces. Okay. We have the separate external force that which we have applied on the block, that was up the inclined plane. This. We had F, it was 20 newtons in magnitude, and we had the normal reaction, which is a self-adjusting force. So that will adjust itself according to the situation demand. So this normal reaction we don't know how much. Now only one thing that you might ask how to do next. कि मुझे पता नहीं acceleration direction कैसा है. Now I don't actually know right now whether it is accelerating down the inclined plane or up the inclined plane. So what should I do? How will I write Newton's second law if I don't know the direction of the acceleration? So the answer to that is very simple. We will make some assumption and we will make the direction of this accordingly. Okay. So if we assume here, if we assume that this one is dominating, mg sin theta is dominating, so our acceleration is along the x-axis. Actually, you can see ये value 25 है, so obviously 25 is more than f. So in fact, we don't even need to assume here. You can see it directly. So but in a more complicated case, sometimes we can't see directly. So that is something. So in this case, since mg sin theta is 25 newtons and f is 20 newtons, so it implies that mg sin theta dominates. Okay. And therefore, and the block slides down the inclined plane. Same problem if I had kept the force as 30 newtons instead of 20 newtons, the other way would have happened. F would have dominated over mg sin theta. Okay. But in this case, it dominates and it slides down the inclined plane. Acceleration equal to a surface. So the acceleration vector, as we saw last time, no difference actually now. The acceleration vector is along this direction. Okay. So now we have Newton's second law, we'll apply it. So net force is equal to mass into acceleration. So components में break कर दो along x-axis and along y-axis. So this time summation fx is equal to mass into ax. So summation fx में क्या आ जाएगा? There will be mg sin theta acting along the positive x direction, but minus f along the negative x direction. So the net force along this direction is the difference of these two. Yes, that one will dominate. But the vector addition better, just if two forces are acting in opposite direction, then what is the direction of the net force? The direction of the one having more magnitude, like that. So this should be equal to ma. That's my first equation. And summation fy should be m into ay, but ay is 0. So this time n minus mg cos theta should be 0. That's my second equation. So from equation 1, we will get the value of the acceleration, the magnitude of the acceleration. Okay, so from equation 1, you can see that the acceleration will become mg sin theta minus f divided by m, which will be 50 into half, that's your mg sin theta, minus 20 newtons divided by the mass, which was 5 kg. So you'll see you get an acceleration of 1 meter per second square. So newtons divided by kg will give you the acceleration as 1 meter per second square, and the direction you already shown, it is down the incline, not up the incline. And from equation 2, your normal reaction is the same as what we got last time. normal reaction is 50 into root 3 by 2, or it is 25 root 3 newtons. No, MA is not equal to F. It is net force. Sarvesh beta, the net force is equal to mass into acceleration. See this equation. So इसमें क्या हो रहा है? When you are solving along the y-axis, it's cancelling out. So what's happening over here is the y component of acceleration is 0. The x component of acceleration is e, because we have taken x-axis along the incline. So that's how in your equation 2, your right hand side is 0, and your left hand side, the net force has to be 0. Okay. Now move on to the third part of this question. We'll discuss that. Yeah, Sujal, I'll discuss the assignment in detail in the next lecture, but you can meanwhile send me the doubts if you have any particular questions over WhatsApp. You can send it to me and I'll help you out with those questions. With today's lecture also, you will understand more about how to solve those type of questions. Yes, in the third part, a 50 Newton horizontal force is acting. Okay, so I'll make the diagram to begin with for you. So is 3. Same 5 kg block, but this time we are applying a horizontal force and trying to pin it against the inclined plane, but not with a force along the incline, but rather with a force which is horizontal. So we are applying a force of 50 newtons. And rest of the things are same. Theta is 30 degrees. So see, as you start doing more questions, you will see you will get more efficient in making the free body diagram, understanding the angles. ये सारी चीजें और जल्दी होने लगेंगी. In another couple of lectures time, you will see this type of question you will be able to do very fast. In the beginning, it's taking us time to understand. Don't worry about all that. Okay, time is not the factor. It's that we have to understand everything in detail. Yes, Devash. Just verify, but I think it is correct. Should be root 3 minus 1 into something. No, Sarvesh, mass into acceleration was 5. So that's why acceleration was 1, because mass was 5 kg. Devansh, there will be acceleration. Acceleration will not be 0 in this case. Yes, Kevin, that's correct. Kevin and Devash, both your answers are correct. Devansh, just be careful about the angles and the resolution. You're getting 0 because you've taken some particular cos theta, sin theta is wrong. Okay. So we go in the same diagram. If I show you, apart from this, what all forces are acting, there is mg acting vertically downwards. and mg is also a force of magnitude 50 newtons, and there is some kind of a normal reaction which is acting like this along this sort of direction, perpendicular to the inclined plane. Normal reaction like this, where we can also see that this angle will be 30 degrees. And let us assume that one of them is dominating. So the block should have an acceleration which is either down the inclined plane or up the inclined plane. So suppose if I assume that it's accelerating down the inclined plane. In the beginning, I don't know which direction it is. So from this, let us convert it to a free body diagram. Okay, so in the free body diagram, you'll see that the forces acting on the body, which of course we will show as a particle. In the diagram, we represent it as a particle. Just give me a moment, people. I'll reshare the screen. Yeah, so the forces which are acting are weight, okay, normal reaction, and this time interestingly the external force is horizontal. But they are same actually, so that's the more significant thing. Now once again, axis and my tangential axis, to take this as our x-axis, take this system as our x and y axis, and not take vertical horizontal. Yes, sorry again guys, my internet connection fortunately is getting interrupted today a couple of times. Just give me a moment. Yeah, so should be coming up now. Yes. So these are the forces. So from this diagram to this diagram, that is your conversion from the original geometrical shape and all that to the FBD. Now also in the FBD, about the angles, it will be pretty obvious that this angle will be your theta equal to 30 degrees, and this angle will be it's not parallel to the inclined plane. That's the thing. It's horizontal. So उसको resolve करना पड़ेगा. But see, the important thing is that if the block moves, it must be along the inclined plane. Yes, Ranak, that's the correct answer. Good. It must be along the inclined plane. Okay. Up or down, we don't know as of now. It must be along the inclined plane. Therefore, choice of axis कैसा लेना चाहिए? Same as above. You take the same as before as the choice of axis. So we have to take, or for convenience, we should take this as our y-axis and this as our x-axis. Horizontal means beta gravity se perpendicular, na? Matlab parallel to the ground. Understanding, anything that is horizontal means it's in a plane which is being cut by acceleration due to gravity perpendicularly. You know, vertical के perpendicular. और vertical क्या होता है, हमेशा gravity के opposite होता है. So that. Okay. So next, let's show the resolved forces. Okay. So next step will be our free body diagram with resolved forces. So this time when you resolve the forces, let me actually annotate and show here only. Then I'll make the full thing. So see, when you resolve mg, ये वाला component जो mg का है वो कितना आ जाएगा? Cos component आएगा. This will be mg cos theta because this angle is theta. And ये वाला जो component है वो कितना आ जाएगा? mg sin theta. Whereas when you resolve f, now notice that f is making different angle. f जो है x axis के साथ theta बना रहा है. So this component will be f cos theta, and this component will be f sin theta. So in future, you know, we'll be doing these things directly. We won't always be making 5 different diagrams. Okay. That I'm showing you today because we are learning all these things. But as you get more used to this, you'll get more efficient in making these free body diagrams. Free body diagram is very, very important. Okay. So when we just look at exclusively the free body diagram here with this choice of axis. So with the resolved forces, you will see our free body diagram looks something like this. This is our x and this is our y axis. Now see that instead of f, we will show the two components of f, which are up the inclined plane and normal to the inclined plane. So these were f sin theta and f cos theta. And similarly, instead of the weight, we will show the two components of weight. So into the inclined plane, mg cos theta, and parallel to the inclined plane, mg sin theta. Okay. Now don't get confused कि ये sin theta है तो ये कैसे sin theta है, you know, ये cos theta है तो वो कैसे, because you understood that in the diagram above with the angles. This is the key thing not to get confused about. F is making theta with the inclined plane. Mg is making theta with the normal to the inclined plane. So that's why the force is resolved like this. And of course, I have one more force which is the normal reaction. Which is along my y-axis. This is my y-axis. Now, many of you would have realized that actually इसका acceleration कैसा होगा? It will happen up the inclined plane because f cos theta का magnitude कितना है? 25√3. You'll realize that this force here, it has a magnitude of 25√3, and this has a magnitude of 25. Whereas mg sin theta, which is the one that's trying to pull it down the inclined plane, that has a magnitude of only 25. So obviously this one dominates. So obviously this one dominates because this force is more than this. So because it dominates, we'll understand that the acceleration will be up the inclined plane. The acceleration will be like this. Okay. But we can still write it formally like this only, because we are taking the x-axis like this. So when we write net force is equal to mass into acceleration, we जब इसको resolve करेंगे along the x-axis. Now strictly if you want to go with this, with proper sign convention, we should write mg sin theta with a positive value, f cos theta with a negative value. But when we solve this, we'll get a with a negative sign. We'll get a as minus of root 3 minus 1 by 5 meters per second. So the minus sign will show us that the acceleration is along the negative x-axis. So negative x-axis का मतलब क्या होगा? Up the incline. Okay. But we need not do like this. We can also alternately do like this, that take the x-axis upwards instead of downwards. So we can also do that. So this first equation can also be written. So this equation 1 that we've written in the proper way over there above. So in equation 1, you can see that f cos theta is dominating over mg sin theta. So therefore, the acceleration is up the incline. When we write the net force up the inclined plane, we should write f cos theta minus mg sin theta is equal to ma. This will give us a as this. But this will give us a with what direction? The direction of a up the inclined plane. This will get with the positive sign. So when you substitute this, you'll see that we get E as 25 root 3 minus 25 by 5. My mistake, it was not by 5, it was 5 into root 3 minus 1 meters per second square, or approximately 0.73, approximately 2.25 meters per second square. Oh, sorry, my mistake. Calculation mistake I've done. Wait. So ये कितना हो जाएगा? 0.73 into 5. 3.65 meters per second square up the inclined plane. Yes, it's correct. Devash. It was correct one. Whereas from equation 2, which I'll write above again, for that is the net force along the y-axis should be mass into y component of acceleration. So this is my equation 2. So when I substitute in this, the net force along the y-axis अभी कितना होगा देखो. There are two forces along the negative y-axis and one force along the positive y-axis. So normal reaction is balancing the sum of these two. So that's another interesting thing now. What's happening? I'll write the equation and come back to the diagram. We have n minus mg cos theta minus f sin theta, and this should be 0 because the y component of acceleration is 0. So again, the self-adjusting nature of normal reaction comes in. पिछले दोनों examples में normal reaction कितना था? Only mg cos theta. But now it has become more than mg cos theta. You can see why now? Because that horizontal force F that we are applying, it has a component which is pushing it against the inclined plane. देखो ये जो horizontal force हमने in the above diagram, if you come here, just give me a second. Towards the end of the lecture. So see, this force that we used to push the block horizontally, this force now, because it's horizontal, it's not along the inclined plane, so it has a component f sin theta जिसकी वजह से वो push कर रहा है against the inclined plane. So that is increasing the contact force, it's increasing the normal reaction. Now the external forces which are pushing the object against the inclined plane, they are not mg cos theta alone now, they are mg cos theta and f sin theta. So your normal reaction is increasing, it is becoming the sum of these two. Okay, so that is why in the equation below you can see that in this second equation, when we solve this f5 wala, n minus mg cos theta minus f sin theta is 0. So from that second equation, you will get that your normal reaction has now become more than what it was in the previous case. Just give me a moment. Yes, that is correct. So from equation 2, normal reaction will become mg cos theta plus f sin theta. So that will be 25 root 3 plus 25. Or 25 into root 3 plus 1. You can approximate that as 25 into 1.73 plus 1 and just calculate how many newtons it is. But this is the normal reaction in this particular case. Okay, so let's go back to the FBD with the resolved forces and our Newton's laws equations once, and make sure you understand the correlation between this. The rest is just solving, but how we came to equation 1 and equation 2, that is the important thing. This will have 5 in the numerator. Yeah. So if we had solved this, just continuing this for a moment here, we would have got minus 5 into root 3 minus 1. So the minus sign here would have shown us this, that is along the negative x-axis or up the inclined plane. Sarvesh, I'll explain. That is then the diagram above. So F जो है कैसा force है? Horizontal force है ना? So what angle it is making with the inclined plane? It's making an angle theta with the inclined plane. So its component along the inclined plane is the cos component. See in the diagram above, you'll understand. In this diagram, see, you'll understand. F is like this. Huh? F is along this direction, and this angle is theta. So that's why this component is cos component and this one is sin component. Okay, so these few questions that we've done today, different parts of a couple of questions, they are very, very important, and they are fundamental examples of how to solve Newton's laws situation when we have multiple forces at various different angles acting. So how to apply the method of free body diagram. Okay, so let's just conclude by me listing out the method of free body diagram properly, so that you can apply it in these type of questions easily from now. So method of free body diagram to solve dynamics problems. First step, for the given body, identify all forces acting on it and make a free body diagram. The body represented by a particle and forces shown as vector arrows. So what is a free body diagram? You represent the body which you're considering as a particle with all the forces which you've identified earlier on it, shown as vector arrows from that particle. Okay. Then second step in this becomes choose a system of axes. That is XY axis. And resolve forces accordingly. So depending on whether the angle with a given axis is theta or 90 minus theta, the component will become cos theta, and z भी ले सकते हैं, मतलब it's just for example. You can take xz, you can take yz. If it's 3-dimensional, then you will have to take xyz also. But most of our problems will be 2-dimensional, so that's why. And the final step, solve Newton's second law in component form. Summation fx is equal to mass into x component of acceleration. Summation fy is mass into y component. So you'll see that we've applied all these same steps systematically to the various different parts of the questions that we solved today. Okay. And this is what we have to learn to do with each and every problem that you are solving from here. All right, people. So with this, we bring today's lecture to a close. Okay. And just make sure you revise the notes and continue working on the problems. Complete anything remaining in assignment 2, or if you haven't attempted some question, just try it out. And whatever questions you are having any doubts with, etc., you can send it to me. I'll help you out with it. We will discuss the assignment 2 in the next lecture in detail. Apart from that, we'll also discuss about tension acting on strings and pulley systems next time. So you can prepare accordingly from the reference books.